Good afternoon, everyone. My name is Christoph Kang. I'm so delighted to be here today to talk about what we are doing in the Oberlies lab, which is using modern analytical techniques for analyzing ancient times. So analyzing ancient artifacts from all times can be challenging even nowadays. Samples over hundreds of years can damage, age, or degrade. Mass spectrometry, coupled with separation techniques such as liquid chromatography, can be a useful application for analyzing chemical residues on the surface of these ancient artifacts. However, most well-known techniques in the literature, even nowadays, requires the sample to be altered or damaged. Here we are presenting a new unique way for which we are using an instrument called the droplet probe that allows us to collect chemical information of the surface of these old ceramics and vessels without any alteration or damaging the original sample. On this next picture, you are able to see some ancient ceramics and potteries that we have used for this methodology and that we have analyzed for searching for ancient chemical signaling residues that can be present on the surface of these artifacts. So our methodology can be seen on this picture above me. First, without any alteration, we took the original pottery and placed it under the droplet probe. The droplet probe instrument has a really fine needle, and the needle has approximately 5 microliter of solvent in it. It's a water methanol mixture. It's an 8:2 ratio, and this needle drops 1 drop of the solvent on the top of the pottery, and after a couple of seconds it takes it back and repeats the process 3 more times. Doing this, it allows the compounds to travel from the surface of the pottery inside the droplet, and the droplet, after this chemical exchange, will be injected into a liquid chromatography system that you can see on the next picture. And the liquid chromatography coupled with the mass spectrometry system is able to generate us chemical information such as retention time, UV absorbance of the compounds. Moreover, it helps us to separate the compounds out from each other, from the mixture, and then using the mass spectrometer we are able to acquire high resolution accurate mass measurements as well as a fragmentation pattern of each compound, which acts like a fingerprint. And basically it's a unique identification code, like a QR code, which is unique for each compound in the literature and can be used for further compound evaluation. Data processing happens after that, and we are also using a technique called mass defects filtering for looking for any other analogs that we have missed. Using these techniques, we were able to generate enough data to identify 3 compounds from the surface of an ancient spoon and an ancient vessel. On this picture next to me, on the top, you can see an ion chromatogram where each numbers represents 1 peak, and each peak represents 1 compound. So we have 3 compounds that we have identified, namely arantamide, arantamate benzoate, and arantamate acetate. All these 3 compounds are natural products that can be found in various plants. And our next step will be to evaluate these plants and try to find a connection between the ethnobotany and the chemistry of the compounds. Now we know the compounds. Our further future goal would be to find the relationship between why these plants were used and why these plants were stored, for example, in these potteries. Is there any reason, for example, they were stored for cooking, or because they are important metabolites for treating various diseases, and ancient samples were used to store these plants, and old native Peruvians were eating these plants, or so forth. So now we know the chemistry of the compounds, and we can have a connection between ethnobotany, archaeology, and ultimately chemistry. So with all that, I thank you so much for your attention, and I wish you a pleasant day. Thank you.